Owl gadget. So we're actually going to be recording sound, a bit of video of the event. So just so you guys are aware, if you have any issues with that, let us know. And then we'll post the link to the meetup group for anyone who wants to go back and review the presentation. Or if you want to send it to a friend, you can share it. And then for our meetup next month, we're still, the location still be to be determined, but we're going to have Alex Simonik back again. I know a lot of people have been asking to hear about test automation, fairly popular topic. So he'll be talking about logging and reporting in Selenium WebDriver projects. So all those details will be posted to the meetup group, so you guys should be able to view everything there. Otherwise, I'm gonna pass this all on to the two Roberts. And they sound like they have a really great talk for you guys today. Enjoy.
Thank you, Jesslyn. Hi. So it's all going to be about the owl? No, it's not. Yeah, hello. Event-driven QA and project management. If you've never heard about it, it's because it's something we cooked up in various projects over the last years, which is kind of a bit unconventional. I just like to get a bit of an overview. This is the QA meetup, so maybe it's who here actually works in QA, as in does testing. Okay. Okay, that's not surprising, right? Who does sort of manual testing, mostly? Let's say who does would say that they mostly do test automation. Okay, who is here from some business management project kind of thing? Right. Yes, something else. You have many. Yeah. Oh, who would say they're a developer, whether they're mostly QA things or not? All right, awesome. Yeah, I'm Robert Reppel. I'm the CTO of TwoTonic Labs, and we are going to talk about event-driven QA. The first test is whether the clicker works. If it does not, awesome. Obviously, it doesn't. Why would it? 1 sec.
Because you tested the version right there.
Yeah, I know. I know. So this is absolutely, that is absolutely the expected outcome. How about we're out now? Yes! Okay. So when it comes to, this is mainly about sort of how to organize testing and what to test and in what order. So you actually test what counts, right? And it's about what matters when. So I don't know, I have this memory of an organization I worked for who had a backlog of, I believe, after grooming, bugs were sort of like, I believe 413 items were left after grooming. They had sort of legacy from about 6 to 8 years, and this a fairly sizable system, and there was still a lot left. All right, let's do a show of hands. Who has a bug fix backlog of more than 500 items? Seriously? Awesome. 300, more than 300 items? Not personally, I mean company-wide, right? Yeah. More than 100 items? Who has no bugs? Oh. All right.
Okay, my phone.
Yeah.
Who has full test coverage?
Yeah. So yeah, this is so. How do you prioritize that, and how do you organize it? They're both from a resourcing perspective and from a from a sheer what should happen when perspective, and this is what this is about. So we're going to talk about events, right? Events are currently all the rage: event-driven systems, event-sourced systems, events back, forth, and center. But what an event really is, it's a thing. It's a record of something that happened. Who has worked on sort of strongly event-oriented systems as a tester or something before? Are they event-sourced, or it's just all about timelines and events? Couple of people, yeah. And so basically, you can describe any system you've ever encountered in terms of events which happen over time. Right here is a fictitious ticket sales, instant ticket sales system, right? And if you can describe any workflow in terms of, okay, if you look back a year, what would have happened? And so, what should have happened? What events happened for particular users in particular context, right? And so let's say you want to sell tickets for a show, right? You get you need to schedule a show so people know what the number of tickets is and stuff like that. And when somebody wants to buy one, you need to suggest the seat. So seats suggested, you need to reserve them, ticket purchased, ticket printed, and so forth, right? So these are all events which happen in those systems. And there's many workflows through a system. The main path through the system, we call it a happy path. Sort of user registered, and then user did all sorts of things to account deleted or something like that. And the entire life cycle of walking through the system, right? It can all be described in events. And it so happens that events are also kind of a very nice way to design systems. Some of you probably, or maybe all of you probably heard of event source systems, where the events are the source of truth. When you need, I don't know what information that pops up on screens and other things, it's all sort of bolted together over time as events occur. You have I don't know, here you have a list of ticket purchases. Let's say you have a list of ticket purchases. You would simply run all the ticket purchase events in the system through that, and you build that for you. And events are supposed to be a complete record of everything that happened in that system over time, which is nice because it's a very powerful technique to do three things. Build very nice, not very buggy systems, organize your work, and make sure your work is aligned with what the business actually wants. Because none of that stuff is about anything technical, right? These are business events. Ticket purchase is obviously a very important event for the business. And so part of this is, how important is that bug? Well, it means that ticket purchase won't happen because of that. And these circumstances, that's really important. Let's prioritize that bug higher than update my profile picture or something, right? So this is the glue which holds that together. Also, if you're of a software engineering bent, when you have that stream of events, you are able to basically determine what they apply to, what content, what the transactional scopes, the transactional little state machines in that system are. Which then allows you to make good calls for refactoring, for implementing, and so on. Because in the end, all software engineering is about managing coupling and cohesion, and managing coupling and cohesion is all about finite state machines, which concludes the comp sci sidebar. So when it's all said and done, here is what this looks like when you add a few bits to it. Can you see that from the back? Awesome. So you have your events, show, schedule, seat, suggested, ticket purchase, ticket printed. But what actually triggers that, right? Somebody is issuing command, schedule show. It's a button you click on a screen. As a result, show schedule happens, and there's a list of shows, right? I'm not going to go into the software engineering parts on how it's implemented in the database or other stuff. That's not really interesting for us here, because this is about QA and managing projects that way. And of course, as a result, you also get tickets available, right? You can simply get a first cut of the screen where you can see available tickets based on show scheduled events. The next thing is you find tickets and you suggest seats, and they are reserved for you for a certain amount of time, right? And pricing category and seats and when it expires and so forth. And finally, someone clicks purchase ticket, and ticket purchased and ticket printed might ensue. I'm not sure if you actually need ticket printed, depends on your domain. And then, of course, you have tickets and the requested tickets popping up on screen. So I think you have some sort of an idea how a stream of events which happen over time can describe any system, right? The workflows. And this is important to realize that these happen in a certain order at a certain time. And that's, of course, something to wrap your head around in terms of actually internalize it, which is why this is not a just sit around kind of meetup, which brings us. So finding those events is a group exercise, right? It's a team of people from all over the business, management, QA, dev, UX designers, anyone who has any stake in this, get together in a room and they do something called an event storming. Who has heard of event storming? Yeah, event storming is kind of all the rage. It was in ThoughtWorks earlier this year. In the ThoughtWorks radar, it was the only thing, process and things in the entire radar at the beginning of this year, which had an adopt recommendation. It's a very powerful technique to quickly understand what a system is about. And it's all about participation, and it's all about actually learning what the system should do by doing, which is why I hand it over to Robert, who will now take you through the human event storming. We're not going to do an actual event storming, but we're going to do an exercise which kind of captures the spirit. Take it away.
So everybody, maybe I'm just going to step on your toes a little bit here, Robert, and that is,
Go for it.
by the time maybe people that are testing the system like you guys are seeing this, it's kind of too late, right? You're not really going to have any impact other than making sure that it works well in the way that it's designed. But imagine the kind of alignment that you can get when everybody from the people who were involved at the beginning, maybe 6 months ago or 3 months ago, or depends on how long you release deploy, but the people that were involved at that time can also talk to you about it, and everybody understands how the system works, what it does, what it's meant to do, and also why we're doing it in the way that we are, right? Because oftentimes the why is the big thing that's missing. You're told, test this thing, and blah, 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 you don't know why or whatever, so it's hard to kind of know what we'd be looking for sometimes. And same with on the development side. Oftentimes they're just like, hey, they're cranking away, but they don't have the full context of what it is that they're doing and why they're building it and so on. Because otherwise they could actually maybe contribute some ideas, say, hey, maybe we can do it better this way or that way. That typically doesn't happen. So the idea of talking about events, it is a way of thinking about the system and thinking about how to model the system. So, and it's different from the way that it's typically done. So what I want to do today with you is just kind of show you the power of how this works. So I've whittled the human event storing down. Normally we have sometimes larger groups, so we've got 18 events. I've got it down to 10. So I need 10 volunteers, I think 10, the other 8 or 10, to come up, and I'm gonna show you what to do once we're up here. But it's very easy. You don't have to say anything. You don't have to talk. But I just want to encourage you to come up. If you don't come up, I'm just going to hand this up to you, and you're going to have to come up. So.
Did you bring the saw and the saw horses?
Yeah, exactly. Thank you. Perfect. Okay, there you go. And so just stand in a row next to each other. There you go. Thank you. Okay, here we go. Sorry, thanks, James. And I just need one more person. Oh, there you go. Come on up. Okay, so now the idea is, okay, you want to look at what your event is. And now you need to pretend that you're from all different aspects of the business. And now you have to put yourselves in the order that you think the system should work in, right? So you want to figure out what is the last thing, what's the actual thing that's going to happen last in the system and work backwards. Okay.
No, you don't.
Order the room after order basement.
So you log in first, then you register.
Place the order first, then they pay for it.
The register. You don't pay for
Oh,
something
okay,
else.
yeah. The system is different, yeah.
Before you place an order. You have to place an order.
Yeah, you can give your suggestion if you want.
Well, the inventory I installed can go for the end.
Right, it depends, right? It depends on your domain, and it depends on what your company kind of focuses on as its kind of value add and its differentiator. So for example, I love using the example of pizza, right? We just had pizza. Okay, so what does one company focuses on? Hey, I'm gonna deliver in 30 minutes. Do they care about some of the stuff? No, they want to make sure that the delivery and all that stuff, they focus on that, and that's their differentiator. Whereas other people, it's like, oh, we do crust, we do whatever. And so depending on your domain, this could change, right? So one interesting thing that we saw, and sometimes you notice it is, they were talking to each other, right? They're like, oh, hey, should we do it this way? Why are we doing it this way? Well, and this is the kind of conversations that happen right at the beginning of the process when they should happen. They're not supposed to happen when the thing's already developed. You're like, oh, how come this thing works this way? This is not supposed to be. Why didn't we do it this other way? You can actually have these conversations right at the beginning so you can build the system properly right from the beginning, which is going to lead to a lot less bugs, a lot more clarity from everybody. So the idea is conversations with stakeholders, people that have different perspectives, right? Because someone in the business side is going to have a different perspective and may have different reasons about why they need this to be in a different order. And you can have those discussions again, very much up front. So thank you very much. That was great. And thank you so much. That was great. Give everybody a hand. Thank you so much. Thank you so much. Thank you. Thank you so much.
There's something else.
Vocabulary. Yes. Exactly. So that's very good. So one of the concepts of event storming is something called ubiquitous language, right? Because in different parts of the organization, they might have some different term in accounting for customer, or it might be an account or whatever, client, but in sales they call it something else, right? So getting that language really crystal clear so that everybody understands what we're talking about when we say customer or whatever, and actually making it really clear and being very intentional about the language so that it evokes what it is you're talking about. So yeah, thank you for that.
To give you an example, it's a good point, right? Do these two belong to what subsystem or app or something? Do these events belong to the same one? Why not? Because if you do your user registration in your ordering system, then you can't use your user registration in your payroll system, and you have to write another one. It's the high-level top answer, right? These are simply not related. User registered. What is that doing in my order processing system? What's a unit? That's not in the same language. It doesn't belong there, right? So this is about identifying what doesn't belong together, which is really that's more the software engineering side, because that's how you determine where one system ends and the next one begins, because that's what causes bugs, right? Ultimately, it's because the subtle ones are side effects, where one part of the system updates state, which is used in another part of the system, and it's kind of a bit opaque why that happens and when. So it's it's kind of the mystery side of software engineering. It's who's seen side effects before, where a part of the system changed after a release and you didn't expect it. Yeah, it's common, right? It's the old if you pop the trunk, the wipers shouldn't go on kind of thing if you were a car. Yeah. All right. So that was the human event storming. Gave you a bit of a test of what an actual event storming is like. You do this in Post-it notes, you brainstorm all the events, then you eliminate duplicates, you put them all in order, you have the conversations. There's usually more than one workflow through the system, all that, right? So we have now done the human event storming. and moving swiftly on to, oh my God, events are eating the world, right? This is a phenomenon. It's been, I mean, I think I've done my first event-based systems. The first sizable one was back in real estate, but it's around 10 years ago, close to 8 years maybe. Not quite, it's something that, no, it's not 10 years, 8 years or something, the very beginning. But since then, this is everywhere, right? Cloud supported, you've got Azure Event Grid, you get Kubernetes, the serverless thing with this on top. This everything is serverless and microservices and analytics and machine learning. It's all about time series events. And why is that? Well, why is that so popular among software engineers and is getting popular? Mostly because it makes for loosely coupled systems which minimize those side effects. You can use publish, subscribe. And the beauty about call and response compared to call and response is that if something publishes, the publisher doesn't know or care who's subscribing, right? Not as such. And therefore, if the subscribers break or aren't there, the publisher doesn't care, right? And so that's one reason why it's so popular. And we're seeing more and more event-driven thinking, right? So what you get is it becomes very popular. And okay, so now we know what an event-driven system is. By the way, is that only for new systems? No, it is not. In the majority of cases, we actually use event storing, and that's specifically us. For existing legacy systems that have the legacy migration. And this forward is my ticket. This is a bike share system, right? This is actually ripped off a real bike share system. I gave you a link to a blog post at the end of this. Kind of describes this was event storm and things like this. But the thing is, this bike share system is legacy and so on. Does actually publish those events like bike unlocked, ride started, bike removed, and so on? I have no idea. I actually don't know the insides of that system, but I can still make a test run and manage the project if I do an event story because they're not published and no one ever heard of events when it was written, or maybe they did, right? I don't even know, but that still happened, right? At a business level, this system will still have an event called ride started, for example. Whether there's an actual event at the technical level published that does that, it probably should be. It would be very useful for analytics and have many benefits. It's a great refactoring direction to instrument your legacy. So it actually publishes events, something frequently done, right? You get a lot of value out of that, from analytics to reporting to building new systems. We don't have to change the existing system, all that stuff, right? But so there's a lot of value in event storing existing systems because you can plan, you can refactor, you have directions, you have guide fences. So, okay, so now we know this. We've done our event storming. There's bikes available at location. The user comes and hits the unlock bike button. The bike unlocked, then starts riding. And so ride started means we can tell from the GPS that this guy is sort of the ride is added to the ride in progress. Then also bike has been removed from that lock station thing, right? And then at the end, lock bike means they have their destination, they lock the bike, and then the bike return event happens, right? So that's great. So how do we, all right, so someone says, test this, or I don't know, implement this, doesn't matter which. How do we turn that into a project plan? Easy. Rotate event storming 90 degrees, right? This is from, just out of curiosity, who here is using Jira? Trello? Awesome, this is from Trello, usually. And so this is just straight out of Trello. You have the read model, the bike availability, database entry, whatever. Then the events, bike unlocked, ride started, bike removed, bike locked, bike returned. And if you recall from here, those are the events. We don't care about the commands. Right? Doing this is, we've done this in a number of projects, and the commands generally don't matter for this stuff. But the events and the read models, because to make them happen and populate the read model usually is work, and it also needs testing. So you go to do, doing, done. Here's your project now. So everything that happens next we run entire projects of this plan where what you would normally do in user stories is actually done based off events. Why is that? What's wrong with you? Who's using user stories today? Yeah, well, what's wrong with user stories? You can just lay that stuff up, right? Anyone can dream up anything and put it into user stories, and it's entirely arbitrary in reality, right? There's all sorts of ceremony, just like Scrum and so on and all this stuff, but it's really a sort of makeup on a pig of arbitrary garbage. Usually, it's to more precisely, it suffers from garbage in, garbage out. Participants need to know exactly what it is and lots of experience to make it work. The funny part is they probably need Scrum to begin with, if that experience, so whatever, right? So it's very difficult. This one gives guide fences, right? Why is that why unlocked, right? Why is that there as a grouping principle, like a user story? Well, it's like it's because it needs to happen in the real business world. You can report status of that. Okay, so imagine this is kind of moved here. Let's say bike unlocked isn't done, ride started isn't doing, bike removed is still there. Status guys. Hey, so how is the bike share system coming along? Oh, bike unlocked is happening. Bike remove is in progress. The bike availability list is already in production, right? And for us, it's in production. So what if there's bugs in this? Do you create a new ticket? Ah, you don't. Just move it back into to do, right? With us, it's like a shuttle, so it looks like a loon stuff shuttling back and forth. Otherwise, you don't. If you create a new ticket for each one of them, it soon becomes unwieldy. You get hundreds of those damn things, and no one knows right from wrong anymore. This way, we have a at-a-glance status, especially as this is one workflow through the system, the most important one. We work only on that. We get it done. And when it's all done, we remove it, we put the next workflow, which is deletions, and whatever, right? Whatever is in the system there, we do them one at a time, and we do the happy path, end to end. The main things users can do first, all the way to production usually. Why is that? Because end-to-end integration is worth almost any cost. End-to-end integration has the hard parts in it. Here's an example of what that looks like. When you populate this list of bike availability things, right? The bike availability in distance to bike returned, bike added from inventory, things like this, and make the database table, searchable thing where you can search for a certain location, you can search for a bike. Called a read model. A read model is a fancy term for whack of information which either users need to see or the system needs to see to make decisions on what to do next. That's a read model. And of course, you need information about bike availability if you want to decide that if you want to know whether there's actually a bike for you to rent at that location, so to speak. So this it could be separate tickets, but here, just because we won't fit the slide, I put it here. This is everything related to that. User experience designer. How do riders find bikes available on location? What does it look like from a UI perspective? API, right? Internet and API, business rules, things like that. What kind of data is stored? This is like from scratch. And this example is for an existing system, but there's similar to-do lists for legacy as well, right? There's any number of to do, right, from DevOps to staging, production, and so on. So you make sure that you do all the hard part right from the beginning and do it end to end. So this is the same thing applies to QA. From a QA perspective, if you have these events, right, in that order, you can start making test plans, right? I'm coming to, we get into the weeds of this, both manual and automated in a moment. But in a nutshell, all right, so how can I test the unlock bike command, right? So what steps do I need to get to a point where I can click that button, and then after I click that button, what are the post conditions? What should have happened as a result, the expected result versus the actual result? And so you can have your test plan and have the test plan initially just for that main flow through the system, and really make sure that it's there is enough test plan so it tracks what developers do who will build this in this order and work on it in this order, but not too much. What's wrong? What's a potential problem? This is kind of as concerned for manual testing, but can be for automated testing as well. So, do you need at the very beginning a full test plan for all of that stuff? You need to test locking a bike, all the rest of it. But if you do that, is that a good thing? If at the very beginning you have a full-on test plan for this, and you make that in parallel with development, what could happen as a result of doing that? The UX guy changes his mind, right? Yeah, this is very, you know what, kind of think that we should change that so the location search works differently. And also when I click that something else should happen. So you can rip up your test plan, and for that matter, scrap your automated tests and start over. Which is why the way to organize it is perhaps worth considering continuous just in time, right? If you have the spike availability rating, whatever is called that, right? If it's just doing that, do you need a test plan for bike locked? No, you don't. You just need you involve your test plan as they work its way through the list and actually build that. All in the industry, you know that that's a very idealized view. As soon as you have a bunch of legacy, which you need to integrate and so on, it gets messier, right? But this is about a guide fence. The principle is prepare your testing on a just-in-time basis, so you don't have to throw it away when they change their mind. That means it reduces the likelihood. So this managing this event-driven means that these things have a higher chance, in our experience, to stay in sync because they're better guide fences, right? You don't have to have a million meetings anymore to decide what parts of the test plan need to be finished first versus the development details. You can all work off the same song sheet. So you have you can have this could have the necessary QA tasks for preparation and setting up test environments, all this other stuff as well. And everybody is working towards making the same event and so on happen, right? And you know you are fully aligned with the business because, well, these are business events. This is not some artificial or gobbledygook from the point of view of your CEO kind of thing, right? This is something which actually, payment process, bike return, you can talk to anyone in business about that, and they will not, because do you have the bike sharing system? Can it have version 1 if you can't unlock bikes? Yeah, we could do a concierge thing where a guy Ubers with a key and unlocks the bike, but maybe not, right? So this puts it into a decision making, into the realm of decision making by better criteria, and keeps dev and QA, which is of course what we're focusing on here, aligned. So how do you, that's sort of big picture, how you manage the project and how you do dev and project planning and QA aligned. Before we get into the week, actually start planning tests. It's kind of participatory. Don't jump up. There's no volunteers. But any questions or observations at this point? Awesome. Let's do some testing. So this is a sort of a usually reductionist view of testing. I mean, I've done many things, including work very early in life. Oh God, that was in the early 90s, right? I actually went into QA for about this was supposed to be test automation for a few months for Ashton Tate. Anybody have a DBase 4? Okay. What happened? Anyway, DBase 4 ruled the world and sort of do it yourself, no-code database tools, right? FOSS, DBase, all that stuff. It was big and it was standalone boxes and client server space. They were huge. Have you ever heard of Ashton Tate? Of course not. Well, some have that, but most of you haven't. Why have you not heard of it? Well, because version 4 was kind of sketchy, to be told them. I was QA and so on, and back in the UK, right? And sort of part of what led to the board acquisition and invention of device were just too many bugs in the thing. So among other things, I wasn't done QA, and I've probably created because it just didn't believe us, it just didn't know things and all that, right? And so I had basically, if you look at this in a very reductionist view, you can plan every single test you ever do in this 100 steps to make. There's a bunch of events which have to be there, right? For example, before you can book, before you can buy a ticket for that show, as in the earlier thing, you need to be registered as a user in the system. So user register must happen before ticket purchase, for example, right? And so you can always have predecessor events and you have successor events. Then I do purchase ticket, and ticket purchase and so on happens as a result. And so these are the events which need to be there afterwards. And you can pretty much plan everything along those lines. So testing event source or event-driven systems, real or imaginary ones, right? It actually does an event source system. Who has heard of event source systems? Yeah, this is the software engineering thing. This is the case where the entire system at the technical level is actually written so that you can sort of reconstitute the entire database, the read side of things, from a stream of events. We did that accidentally on yesterday on our systems, and sorry about that, it was operator error on my part. So you can actually, oh my God, I used a live database, all the tables are gone, right? All the tables are gone, and because when you do the system upgrade, I accidentally triggered the piece which replays all the events. In this case, the system has been live for a year, yeah. And so it was posing a year's worth of events into the empty tables, causing the live side, parts of the live, don't ask, to be down for a considerable amount of time.
A year's worth of IoT data.
IoT data from never mind. So basically, an event source system is a system where you can actually, that's the real deal, right? You can actually nuke all your tables, then hit it with an event stream, and it rebuilds all your tables with all their content from scratch. We have built most of our systems, except for two, the last 4 years in this way. We have still a specialty to build event source systems, and that's where we discovered that you don't actually need an event source system. Imaginary event source systems are perfect from a planning perspective, because whether you're refurbishing legacy or building a new system, you can still do an event storming, and then this planning and QA managing and things like this, which we're discussing here. So let's see. Let's have a there's always commands, just a refresher commands, register, and then the registration started and registration confirmed, stuff like that, and there's these events in orange, and then there's the database tables with stuff which is being read to display on the screen, stuff like that, right? And so what do you test? We talked about pre and post conditions. So, all right, so this is any button you click, which results in a database update, is basically a command, right? In this world, it's a command which results in events if it updates, deletes, or inserts in some data store. If you change state of the system, that's recorded as an event. And so how do you test this, right? You test it by having, it doesn't matter if this is manual or automated testing in a test framework of choice, right? I'm not going to show code examples to do an automated test, but events, preconditions, events that must have happened or that not have happened before you hit that button, right? For example, you can only even get to the button if you can log in, okay? You can log in, registered users can. So user registered is a really good event to have before you can do anything, and before you can hit any button. So it's always preconditions, right? So those are your steps to set up the test. Then you hit the button, and then there is expected result, right? Post conditions. Which events must happen if the command succeeds, or what errors are there when it fails. So let's have a look. Let's see what. Let's say you are interested in. Oh, I don't know. Before you can. This is again this bike share system, right? And one of those things is you need to add a payment method before you can take a bike out. You need to leave a deposit, right? And for that you need to give a credit card. So you are tasked with testing. Let's go manual for now, right? You're tasked with testing whether the adding of a MasterCard payment method actually works as an add payment method button or something on some screen. What events must have happened before this can happen? Events are the orange things, right? So what must have happened before you can ever click that button? Remember, this is the timeline from left to right.
You should have logged in and you should be registered.
Yes.
And
yes, exactly. So you need to register, which results in registration started. Then you get your email this, which means a confirmation link. So that results in registration confirmed. And then you could set your password, set up a password updated, right? Only then can, in this system, only then can you add a payment method, because clearly if you put your credit card in there or payment method, it would be good to know who you are. Exactly, right? And so this gives you a sort of a guide of what needs, if you're doing QA, what needs to be there first and what are the previous steps in your test plan. And of course, if you are the implementer of this, it gives you a guide of what needs to be implemented first. So in this way, you get a clear idea of the preconditions of the test. So what happens afterwards, right? If this is successful, an add payment button and the test passes, what is the expected result? Yeah, the profile should be updated. As you need to check that screen, the read model, right? Or that's also known as a screen and not speak. It first of all should come up, but then it should have the last 4 digits of the credit card, and somewhere in the database there should be a credit card token. And your event log should show, and this is just a straight up log, right? And never mind the technology, very important. It should show the event called payment method added. See, that means it's a success. So here are the predecessor events. This must have happened before, right? And this is what you need to test afterwards. Payment method added has occurred, and my profile has been updated. This is, of course, stating that in terms of events is very powerful in terms of because you can also test that in code, right? You can have a payment method, let's say little microservice or whatever you call it these days, and it has a method called a command payment method, and as a result, it should produce this event. And of course, you said that other events which are predecessors and so on and so on, right? So that's of course gross oversimplification, but in practice, it makes nice easy to refactor, not tightly covered automated unit tests, which don't have to deal with horrors such as box and other stuff, which just is coupling and slows you down. So it makes for pretty elegant testing, but that would be another talk, sort of the development side of that stuff. So this is high level, of course, but how you go about planning individual tests, right? The focus on the manual thing, right? And you have so the command processes. Command is anything which results in something changing in the database, and there's a record of that by publishing an event, which remembers that this happened now. So that's one thing which consists of the system. The second one is read models, right? Again, stuff. The read model is any whack of data which is used by either users or the system to make decisions about whether it can, to make decisions about what to do next. So, in a nutshell, if you want to know if let's say, for example, that your email must be unique in your system, very common requirement, right? You can't register in our hypothetical bike registration system with an email which is already in it. What do you need to know when somebody does a new registration? Well, you need to know who's already registered. You need to have a list of emails of registered users as an input to whatever command processor evaluates whether anyone can actually, whether that is valid, whether they can register this file or not. Right? So basically everything, that means you need a read model of existing registrations in order for that command to run. And those read models can, of course, be very complicated, right? You can have your read model can be anything from something which is a table which stores a single email, traditionally list, like in this example, up to an entire elastic search full text search database, which contains 3 variable analytics stuff, right? And everything in between and beyond that. And they need to be tested too. Now, the thing about testing those is, again, the preconditions are all the events. For example, all the events, so we have a subscriber who subscribes, for example, to all the registered events. So we can email a freshly registered user to the list of already taken emails. So that again you can test automatically by populating by feeding this read model to all these events, or manually. Manually is in this case more sketchy. So that way you test the read models by feeding them events. Now, the last thing, trying to not digress too much into the software engineering side, the third artifact you test are process controllers. A process controller also listens to events, but it makes decisions on what command it can legitimately run, right? It decides what command to execute next based on events. For example, if there's a payment failed event for this, then do not ship order. Do not issue that command. If payment succeeded, then issue a ship order command. What then is a process controller? You are, because it's basically no different than a person. So it's basically no different than a person sitting in front of a screen, reading things on a screen, and deciding what to do next. Right? You look at something and you decide that, okay, that's good, let's click that button or do whatever. Right? And so only in process, so this is called loop stack testing, right? The process, what events must have happened put in your test plan, and then and how to get there, and then what commands, what button is grayed out or not grayed out if you want. It's the same for robotic process controllers, if you will, like the thing which makes a decision whether you can register this email or not, because it's already a registered email, would be the exact equivalent of someone looking at a screen and deciding to click or not click a button based on something they see. There is no conceptual difference. So whether this is a human being or some automated process, right? So in a nutshell, you will only ever test three things. You will test command processors, which change the state of the system, and will which either, depending on the preconditions, can legitimately do so or not. But, if they change it, it's an event. If not, then it's some sort of error message, user feedback. The second one is you will test read models, something which some database table or something which is updated based on things which happened in the past, and you then need to do various levels of testing to make sure it's accurate. And the third one is process controllers. The mechanical kind, also known as the saga or whatever, I think the programming kind, but really it's the same as people doing workflows manually. Only three things to test. I can't think of anything else really. Questions before we move on? Awesome. So let's see. Prioritizing fixes. You suddenly have a lot more in your toolkit in prioritizing this stuff. I mean, this was a somewhat high-level thing into the details of how you do tests and so on, and what you test. I will say that most of my testing in recent years was automated testing. So this would have been a lot, I guess, probably examples would have been good, but I wanted to keep it a little above that level because this was mainly about organizing tests around that. And so these were sort of decision criteria on what you want to test and for what reason, working backwards from your events flowing, right? Prioritizing fixes, how important is that bug? User profile picture changed versus payment process. We talked about that at length. You can tell by looking at the business events and simply make the decision together with the business of what you test first. And of course, end-to-end integration is job one with a happy path, what most users usually do. And so to summarize, you do an event storming of a new or existing system. Often if there's if it's about understanding the status quo, it's one event storming. And we've done for the future state, what you actually want to build or where you want to be in the future. That could be another one. And then the delta goes into the planning and testing as well. That's more involved. Then you basically turn that into a project plan by basically turning 90 degrees, make it into to-do list items or whatever it is, and plan around that and put them in that order to the perspective. Now, where have we done this in a number of systems or in recent years? At the moment, just rolling out a very simple one, which was actually mostly manual testing, organized, not entirely unlike what I just described. It's a very simple basic. Yes, what it does is it's highly specialized for dealing with interruptions at work. It integrates seamlessly with Slack for one purpose only. It shuts off Slack and all notifications, so you stay in the zone. That was kind of one of these hard to explain things. We're currently dealing with the application to get into the Slack App Store. Oh, what features of Slack are you using? And this is basically we just wanted to shut up, so the only one we use is do not disturb. Anyway, that kind of thing. It's basically deals with interruptions. It makes people more productive and they can understand where the time went better and all this kind of stuff. So this is an example of something simple we built, which is one of the projects we used this way. And that's an event part, a small sliver of the event storming, and a couple of lead models from that system, which we actually use in the wild using some of those principles, which I just described. Note that there are no commands, the blue boxes are missing, just the events and the read models. There's a list of tasks and there's Pomodoros, which you did, stuff like that. There's much more to it, but high level, right? Task created, Pomodoro started, counter created, Pomodoro completed. And the reason why for planning purposes we don't do the commands is because in the project we did this way, we found that then they don't add any value from a planning perspective. As the unit of grouping things together which need to be synchronized. Events are great because most of the work is in making the events occur from UI to API to everything. And the read models are very important because, again, it's a lot of work to make sure that the right data are in there. The commands are usually just about evaluating a bunch of business rules that we have so far not seen. We dropped it, but it turns out that the units of planning, events, and read models are really good for this. Well, this brings us to, well, they're doing not too bad. This concludes the talking part of our event-driven QA, and for that matter, project planning talk. Hope it's food for thought. If any of you think that any of what I said and how to plan backwards for events that way is best practices, forget it. This is all stuff we have evolved in over the last four years or so in-house in various projects. This is sort of hand-rolled. So we may be crazy, but it actually works pretty well. So questions and sort of, I want to hear the chorus of "you must be joking, this never worked, this will never work." It does, but that's not the point.
I have a question.
Yes.
On the approach that you showed us earlier in the Trello board,
yeah.
Is there any example where there's a bug existing, but you decide to not fix that bug due to time constraint or a resource constraint?
Yeah, absolutely. I mean, you have a situation where, if you go back to that slide, you have a situation where here, right? Let's say, see this is 0 out of 3 or something, and let's say this would be I didn't update the slide, right? But let's say, forget what it actually says, right? We can use this by having sort of bugs with links to wherever, stuff like that. Those of you who know who's Trello would know what to do. Imagine this is a bunch of bugs which need to be fixing related to this read model, and you simply choose not to, right? You choose not to, and then because, especially, I don't know, I forgot, I'm blessed, I forgot most of my Jira stuff. The point is, in Trello, see where it says 0 out of 3. Imagine this isn't done and it says 2 out of 3. So somebody can say, oh, why is that 2 out of 3 and it's done? Let me crack that open. Okay, there's no check mark against it and a brief note which says not fixed at that point, maybe next version, something like that. Maybe you that in whatever file tracker of your choice. But the key point in this is, again, visibility, right? There is an outstanding issue. Maybe it's for the next version. What does it affect? Oh, I don't know. It's something to do where removing a bike didn't quite work, but it's an edge case. Oh, okay, I understand. Okay. If it had been something about registrations failing, that would be a showstopper because we want as many users, so user register mustn't fail. But this is okay, especially if it's an edge case done. So yes, visibility is key, and again, you have the advantage with this method that it's easy to rationalize why it has that importance versus something else which has a different importance because it goes back to business events. Other questions? Yes.
So one thing I think I heard you say was that your event stream is kind of like your source of truth.
Yes.
So what happens if you discover there's a bug out in production and it's basically putting bad stream.
Yes.
So obviously it's like, okay, we can figure that out. We can make a change so that that doesn't happen anymore. And you still have effectively a set of events which don't really, they're not really what you wanted to have happen, even though.
Yes. It's of course something we all know, right? So you have basically, if I understand you right, the traditional network system often have a non-event source system, which is this phantom events to understand the environment better, right? And that is the same practice, it's just something that you promote because it's very useful. You would basically have your DBA, for example, do a database patch and just patch up the data and in a traditional system. Is that sort of what you do, that kind of thing?
Kind of, like if it was, if you were not using event streams, and
Yes.
it was a bad value in the database,
Yes. Yeah.
then you're broken right now.
Yes. And for the way there's a number of things in how you do that with an event stream, which usually on the face of it are more complicated, but done at scale and over years actually are much simpler because you can easier understand what happened. It's not so random, right? And so in a nutshell, there are broadly speaking, there are two ways of approaching that. You either fix it at the publisher or at the subscriber end. I mean, it's really, really broad. We don't have the time to go into it. If you fix it at the publisher end, then you would, for example, publish a new version of the event, which has the missing data, and subscribers would have to update themselves and stuff like that, right? Which of course comes with a whole snake pit of complications. Update all the subscribers at the same time. So there is a whole book written by Greg Young for event versioning, which basically tells the entire story and brilliantly so. Highly recommended if you're in that space. You could spend until 4 p.m. and so on. The other way, and I will say this is the one we usually took, is you do it at the subscriber end, where that database value, which would normally patch, is of course inserted by one of those subscribers, which listen to the event streams. So you just do the dirty deed by doing the database. So if that event if you're missing a data field or something, you need to change the value. You simply do it by hacking into by changing the actual subscriber, right? You would play an event stream which has perhaps an additional data value in it, and a new version of that read model builder would know how to correct this, right? Or it's not even additional data. It's just there was a bug actually populating the database from the event. You just replaying the event stream, which at scale has its very own challenges, because that triggered into the data accident took several hours to rebuild the read models, right? And that's you can do that if you have a huge production system with oodles of data, right? So one approach I think is, it depends on the domain, but you actually don't do that. You do it when a user logs in and you check, oh, the read models of interest for that user, are they up to date with all the latest? No, that's data. So instead of a big nightly update overnight, which does the entire system, it does it in small chunks on demand, if you will. Not always, I mean, right? It's not always, there is no, the problem with all of those problems, with all of those things is there's no one size fits all. It's entirely dependent on the architecture and the problem you're solving and the characteristics of the system. In that sense, it's not different from simply patching the database directly. That too has no one size fits all. Complex area. In this one, so it's easier to test and actually a little saner to handle than the traditional method. Mostly. Other questions? Yes.
With the event-driven testing, do you find it necessary to do a lot of integration testing that events get published and then something further down the chain actually receives it and processes it properly, or do you find that you do more testing based on individual events separately?
Usually more around individual events. Usually we've had, for that kind of end-to-end stuff, we usually find that from an automated coverage perspective, we usually have sort of small number of end-to-end tests, and it's usually testing the individual things, and we got away with it. But that's because most of our systems, Commodore's what I just showed you isn't, right? It's not an event source system, it's an event-driven system, and you couldn't constitute the state of Commodore's from events. That wasn't necessary for something simple like this. But most of our systems, like an IoT system, which the testing, it makes for better little state machines, right? It makes for better, if you're a domain-driven design versus aggregates, if you will, or transactional scopes or whatever. So you simply get less side effects. You can be a lot more confident that you don't get as many side effects. And so less of those big end-to-end things turned out to be necessary. Touch wood, I mean, so far. But again, your mileage may vary, right? It depends very much on the domain you're working. Other questions? Yes.
I'm trying to grab my head around, like, if you're working with the workflow, like having advance moving left to right.
Yes.
But like in more complex workflow, you may have very many branches.
Yes.
So that's not quite as easy just to take an angle view. Like how would you then
use a chainsaw.
Yeah. Or you have to have so many different 90-degree turns.
Yeah, and which is this is if you look at this is not so the answer to the question is yes, there could be many branches. We don't generally represent them as branches, we use several workflows. But you know, there is I don't know if you have sort of studied Toyota manufacturing type of thing. Who has heard of this? Yeah, so the lean methodologies, right? And I think this is its ground too. It's basically batch size, right? You want to keep small batch sizes of work, and because work in progress, the more work in progress, the more meetings you're going to have about work in progress. So, which is why we usually all those branches, and if we do only the happiest happy part of the happy path through that bike sharing system, right? And we simply only do one workflow at a time. Hopefully, the happy path, what you came from beginning to end, on average user will use it every day. And we concentrate on getting that done. It's done all the way to production. Then we delete that board, or it's all done, all archive everything on it. And then you do the next branch. All right, it may a branch here which starts with right start. It's just the right start is first event. You just do that part, right? So the entire team or teams are behind getting this thing in production. So the branches are there, but we don't represent them at the same time in there because this is, of course, being branch is very appropriate. It's a wood from the trees thing. For planning purposes, if this didn't add any value to it, you have that on the board if you don't already work on it. Other questions?
But you can follow up.
Sure, go for it.
Because if you're doing it like one at a time, then you may not be exploiting potential efficiencies. If you're from a QA perspective, event development, if there's multiple branches, one particular event, it may be easier and more efficient to do that all at the time.
It is, yeah. In that case, that's in case of Trello, the boards are more. However, and that may be, the caveat here is like the techniques I explained. They have used that in some teams of up to 12 people who work on it. So fairly sort of pizza-sized teams working on fairly pizza-sized problems for up to half a year or something like that. And various versions. And so if you would roll that up into a sort of 5 pieces of complex integration work coordinated, and we have the central QA for the test for that, and we would have to think about the issues you raise, right? So when I say that this worked for us, in most scenarios, simply ignore risk. One possible reason for that is because we haven't tried to scale it to what your to something where it matters. I actually tell you think of it based on your remarks, I actually suspect that to be the case. We tend to work with bigger teams than other projects.
Yeah.
Yeah, how many teams and how many people do you normally have on projects?
I mean, we have some large transformation projects that are here have like 60 people on it.
Yeah.
And then also multiple portfolios happening at the same time. And releasing test environment and like release management, functionality. So yeah, so okay, so this would be more for smaller projects.
Well, I like to think that it works for bigger ones as well. It's just that I haven't used it in bigger ones yet. So I can only speak to what worked for us so far. With all that, if you are interested in a kind of lunch and learn scenario, or just again getting together and think around a bit, and bring up exactly the kind of thing which you just brought up, and kick some tires and so on, this will talk to us afterwards. I would actually be very interested in that. To just work more heads on that. Yeah. Other questions? Yes.
How do you approach test mitigation test like the last scenario, which is like backward time, wherein a whole lot of steps have to happen.
Yeah.
But then doing that scenarios might cause test flakiness because other behaviors might not work or might require time, might increase the test time, test not that.
Yes. Now there you get into a larger an actual event source system. We have actually a real scenario. We kind of fake it. If you look at, for example, see this, right? You have here, right? You have. See, we talked earlier about the predecessor events for this. But imagine way down, right? It's a complex user profile. Let's think of this being some sort of database search thing which comes from 200 different scenarios. Well, you know what? And let's say a lot of the stuff that actually produces those events is actually not implemented yet. Well, what we have actually done for real, we have faked events, right? We have created a JSON which represents the events by hand or by whatever is necessary. This is what we expect the events to look like. And we populate them with junk data and we play them with all the test data. And we play them into this read model and then appear on the screen as if everything already works. That's also the way of analyzing the work. That's something we've done quite a bit in a number of systems, but this year and last year. And that's how we can get around this test setup. As long as we know what the signature, the schema of the event is, and what data and types and stuff are in them, you can do the test setup by just replaying the event. Like I did today, in the very drastic test. I'm happy to report that it actually works, which is good because it was in production. Anyway, other questions? Yes?
You found that when you do the running up interesting results, because I'm what you say in the project today, I'm supposed to read as a developer. I'm supposed to have my list of events and test I have that result.
Yes.
So you are also testing the exact same thing.
Yes. I wish I had some code there, but when we look at that, I didn't bring any code, which is because of a mistake. But this thing where you have the pre and post condition, right? There was some. Yeah, the stuff which needs to happen before and after and all that, right? When in the more developer-centric talks being given this, you can literally look, in this case, the examples are mostly in Node, and you can literally see the tests where you have those command processor things, and it really has you feed it an array of events as an input, which establish some sort of state. For example, all the 5 different user registered events, each with a different email address. Then you execute the register user command, which will return an array of resulting events or not, right, or an error. And so you literally structure the code this way.
The QA?
Developers.
Yeah,
Developers, right? It's also because the dirty secret of doing unit tests as a developer is it's not about testing at all. That's bull. It's about it simply leads to loosely coupled, more cohesive code. Unit testing, because by definition, if your whack of stuff can be called from 2 places, the actual code and the unit test, almost by definition, it means it's better structured code. So it's just a tool for structuring code. Who cares about the tests? Anyway, that's my take on it. I stand by that, because it turns out all this 100% coverage mania, which is thankfully abating, well, guess what? It's coupling all by itself. So all your tests are coupled. So you're slower in changing things, because constantly on a pile of tests breaking, where half of them, no one knows what they mean anyway. So it's a double-edged sword, I think. But I would not write anything complex without decent test coverage, but not because I care about the tests. It's because it makes higher quality code as a result. The tests are nice. I know this view is not actually, it's gaining some ground.
But what I'm saying is,
yeah,
in this kind of design with different sourcing,
yeah,
if I'm a developer, I just have to test the exact same thing as this. I'm not doing some internal test or just for progress or something. I'm testing with this event, this event, this event. I have results.
Yes. Yes.
Only test I do.
That's usually what we did.
So it's the same.
Yes, it is.
For me, I would need to change what more on the food process.
Yeah, what we normally do is we actually normally don't. In the systems we build, and as I said earlier, right, and usually in the bigger picture of things, we're not talking about 60-person 5-year effort or something. But what usually we do the tests like you described, fully automated, and then just exploratory testing, which is actually centered very much on UX, not just find bugs, but user experience testing kind of thing, right? We find that we don't need the automation at that level at this point in the system. So far, your mileage may vary. So we kind of just don't want to sort of be a bit respectful of the time and so on. Time for one more question, I guess. Yes.
So for this, it's very useful. So, for example, I use this strategy that for person do it. Yeah. What's the typical mistakes that you would see that we need to do in this kind of process?
It's about introducing it in a way where people don't feel safe and feel threatened by you introducing them, right? So it's like there really is no technology in any of that. It's all about making sure people feel involved, people comfortable, people feel safe. So if you were there, that user story stuff and the 100% test coverage thing, and all the Jira shuffling weird cards and points, that's garbage, man. Check this, you have already lost it. So it's headspace stuff. Incidentally, you get, because you plan in terms of tests, I didn't do that, right? But because you plan in terms of events, we found that there's statistics to have, because in the end, across we have the data for 3 or 4 projects, right? In the end, you can start making statistics. Okay, to do one event, everything from UX to something. At this phase of the project, it's going to elapse time this much and billable hours or whatever this much, right? So we actually use those statistics for estimating. For some reason, possibly because it's a less arbitrary way of grouping stuff together than user stories are. And of course, this may not work if you don't actually build an event source system. Event source systems tend to be architecturally very, very similar one to the other. We actually found it's a very powerful tool for estimating. So yes, thank you very much. And thanks for coming.
Tonight, we'll be posting the link to the video and probably links to the slides as well, maybe separately to the meetup group, so you can look them there. Feel free to share them with your colleagues or friends. And then I will post any of the next meetup information as well on the group. Great, thank you guys so much. Have a great night.